Hello, this is Dr. Zhang. So for this video, I'm going to talk about your exam preparation for EE3005 systems and control. Now, to start, let me give you some housekeeping announcement first. The venue of the exam, has been changed. Originally, the venue is now changed to the venue has been changed to TTR, which is the table tennis room. Do not go to the original venue, which was announced earlier. And your exam is on the 18th of December, and from 15:15, 3:15 to 6:15, so 15:15 to 18:15. Make sure you arrive on that date, on that time and on that venue. They do not mix up with anything else. Right. So the next thing is how about the projects? Now the collection of the emails you go to the website. You go to the EE3005 web page, and then there is an announcement on where to collect your emails. If you I don't want to collect it, doesn't matter. You don't collect all the things. It will be cleared up on Friday. So if you don't get it on Friday, actually it's not clear up on Friday, it's clear up on Monday morning. But I suppose you don't go back to the PolyU on Saturday and Sunday. So the deadline to collect your emails is December 5th, Friday. Right. Then the next thing is when should I hand in the report deadline? Now I have told some students, the absolute deadline is on the day of your exam. So before you enter your exam hall, make sure that all the things have been submitted online. So during the exam, I will switch off the upload function, and you cannot upload your all your stuff. So make sure you do this. Right now, next let's turn to our exam, how to prepare for your exam. Now before I actually go to the details of the format of the exam paper, I will tell you a few things. The first thing is be sure that what you put in your answer script is final. What does it mean? It means that now during the exam you see a lot of questions. For example, Q1 to Q how many? Q1 to say Q9. Question 9. There are 9 questions. But what you should do is, whenever you read a question, you think about this for each question, and then you do some rough work. I will provide some rough work paper for you during the exam. A few sheets of rough work paper during the exam. Okay, so you do it on the rough work, and then you say that, oh, this is good enough lah. Then you transfer your final answer to your answer script. Okay, so many years, years, I've seen students writing. Once they sit down, they start writing, okay, without even thinking. Write a lot of things, and then afterwards, they will just cross out. Then the whole exam answer script, 90% has been the crossing out. So it's very difficult for me to mark, and I will definitely miss out some of your important points. So you will receive less marks. So for this year, I will provide some rough work paper to you, and then you will do it on the rough work paper. If it's okay, then you transfer it to your to your answer script. Okay. Now then the next thing is okay, since there are 9 questions, so it means that each question, it will be 10% or 15%. And if you do the mathematics right, you'll notice that there are 2 questions which belongs to 15%, and then there are actually 7 questions belongs to 10%. So altogether is 100%, like this. Okay, and then you realize that for our teaching, how many lectures did we have? Excluding the tests, we had around 10 lectures. So it means that most of the stuff in each lecture is examinable. Okay, so no need to say that I don't like this topic, or I will choose a different question to answer. You must answer all the questions, and all of the questions will spread over the whole entire 10 lectures throughout. So it means that you can't really skip one topic if you really want high marks. Okay, I do expect you to get high marks. Right, so that is the key things. Right, the next key thing is about the graph. Okay, there is some lean log graph paper. Now for the lean log graph paper, be sure you know what is the orientation. Okay, the orientation for lean log graph paper is y-axis. Okay, that's the graph paper. The y-axis, this part is linear, and for x-axis, this part is log. Okay, and for the log, if you want to draw the body plot, suppose there's a body plot question, you need to divide them into 2. The best thing is draw the gain function on the top half of the plot, and draw the face on the second half of the plot, like this. Okay, so this is on the lean log paper. Now some of you don't even know what is logarithm graph paper. Okay, I just give you some understanding. Okay, so logarithm graph paper must be in the form of 10. Okay, so if I say this is 1, this should be 10, and this should be 100, and this should be 0.1 and 0.01. Okay, this is the frequency scale. And of course, if you look at the logarithm scale, where is the 2? Okay, 2 is around 1/3 of 1. Okay, so this is 2. So and then it will be compressed like this. So and then there's 5, 7, 8, 9, 10 like this. So it is compressed towards the right hand side. Okay, so if you got this wrong, take it left hand side. Okay, everything will be wrong. Okay, so this is the log scale. Just in case you don't know what is log scale, if you don't know what is log scale, I don't know how you can pass your exam. Okay, so this is on the lean log graph paper. And then there's another thing. Okay, how come I do not give you normal graph paper? Now, for normal graph paper, so what do you think? Expect you to draw some of the graph. I think the other graph paper probably you need to draw is the root locus plot. If there's any question on this one. Now for the root locus plot, you obviously know that it is just a sketch and it is not accurate. Okay, so it doesn't need to be accurate. So what you need is you just plot it, just draw the root locus on your normal answer booklet. It's okay. Once I see that your shape and size is okay, then I will say, oh, okay, this is it. So you already passed. Okay, so it's like this. Okay, no need for you to be very accurate. Okay, I just want the shape to be what I've expected. Okay, what I've expected, then you will be okay for the root locus. Okay, right. So the next thing is how you should answer the questions. Now I give you a few hints. The first one is no long essay. Okay, and the second one is points form. If you want to highlight the words, you may highlight keywords. Okay, so in that case, it's very important for you to bring your calculator to the exam. Okay, pen and, for example, pencil, and then there's a highlighter. All these things are important because you of course you need a rubber lah. Okay, if you draw anything wrong, so make sure you all the drawing elements, all these tools are available to you. Don't just during the exam and then you put your hand up and say, oh, yeah, sir, I forgot my calculator. Okay, if you do this, I cannot help you. Okay, you just count with your fingers. If you do not have your calculator, no way that I can help you. Okay, so this is the important thing. Now about the lean log graph paper, is attached to the back of your exam of your question paper. Okay, attached to the back of your question paper. So what you need to do is like this. Okay, you receive your question paper. Okay, there are many pages like this. Okay, at the back there is the lean log graph paper. Now what you do is you pull this out, okay? Pull it out from the answer script, no, from the question paper. So this is the question paper. And when you hand in, you have a booklet, okay? You have an answer booklet. Make sure you pull this sheet out, and then you tuck it inside your answer booklet, and then you submit. Okay, no need to put a string or put a nail or whatever. Okay, just clip this, put it inside tuck it into any page of your answer booklet, and then you just submit the thing. Okay, what I'll get is I get the answer booklet with your lean log graph paper attached inside. Make sure you put your name, student number on the lean log graph paper. Okay, this is very important. Okay, you make sure you put. Okay, so much so for the how you answer and all the things that goes with it. Next, we will look at individual notes, okay, of each lesson, and then go through it and tell you which is more important, which is less important. Okay, let's start from lesson 1. Lesson 1 is about introduction to feedback control. Now, when you talk about introduction, there's not much that you really need to know because it's just introduction. So when you go through these notes, okay, I'll tell you what is important. This is you need to understand all this. I will not ask you what is the meaning of control system, what is the meaning of input, output, closed loop, open loop. Give me the definition of this one. No, okay, there won't be any questions on this. Okay, this is too basic. Okay, so you don't need to learn this. The good thing about feedback control, the bad thing of feedback control, this is still too basic, so no. Okay, so let's go to block diagram. And of course, you need to know the basic manipulation of block diagram. Block diagram. Otherwise, you won't do anything. You don't know. If you don't know anything about this subject, of course. So you need to know. Okay. The plan, process, control, feedback, all these things, you need to know. Okay. You same thing. You need to know, but we will not specially ask you in the exam. Okay, not specifically ask you in exam, but you need to know. Otherwise, you don't know how to answer the exam question. Okay. Well, so that is it. So you see, for the note number 1, not one item is examinable. Okay. So this is not note number 1. Okay, it provides you some of the basic information, but will it be in the exam questions? No okay, it's too basic. Okay, so make sure you note this. Then we go to the second question, the basic or the differential equation and Laplace transform. Now, let's go through it page by page. I suppose you know what is differential equation. So if you don't know, okay, you just need to learn the mathematics book yourself. But that is not the specific examinable items in the exam. Okay, all these are giving you just to attract you. Why is it important? But will we ask you in the exam? Probably not lah. Okay, all these things then we go to the Laplace transform and the Laplace inverse transform. For example, Laplace transform is this equation. Some students will ask, 哎呀，死啦 very difficult to do. Okay, change the function to Laplace transform. It involves integration. I am not so good in integration, so I tell you now, you must make use of your lookup table. So the first thing you need to notice is go to our website and study hard on the lookup table rather than doing the actual integration like this. You need to make good use of your lookup table lah. Okay, so this is important. Right, so the first thing is Laplace transform. Now for this one, find the Laplace transform. Okay, you need to notice lah by so this is you just go through it quickly lah. Don't give a full take means that is important, somehow important. The next thing is how to find the Laplace inverse transform, particularly partial fraction. I tell you, it is very important. So make sure you know what is partial fraction expansion. If you don't know, you're hopeless. Okay, so you need to know what is partial fraction expansion, because and then from there onwards, you need to know after the expansion how to find the Laplace inverse transform. So this is very important. Okay. This is a very important example. Okay, make sure you understand this. Okay, so there are some examples like this. Now, here there are a few things. Make sure you know that there are two things. First, what is the initial value theorem and what is the final value theorem? Okay, these two theorems are important. Okay, so you need to how to manipulate this. Okay, it's not difficult, but you need to know lah. Okay, for example, I want to find the steady state error. Okay, and then you need to use the final value theorem lah. Okay, for example, steady state error. For example, I want to know what is the initial value when the function starts. So you need to know what is the initial value theorem. Okay, so this is the initial rise, for example. You need to know the initial value theorem. So these two are important. Here they tell you more in detail. So make sure you go through this now. Right? So important. Study this initial final value theorem. Okay. So already that's what you need to know for this Laplace transform. Okay. So let's go to the next slide. Next pile of notes. Now for the next pile of notes, we go to the transfer function and system block diagram. Okay, transfer function and system block diagram. All these are very important, but not really for the exam. Okay, this is just for your general knowledge. This you need to understand this okay, but not examinable. Transfer function you need to understand, but not examinable. I will not ask you What is transfer function? Definition of transfer function. Of course, you won't get this type of question. Okay. The feedback control, all these. Now, this is modeling. Okay. There will be one question on modeling, but for modeling, there are two types of modeling. First is modeling of electrical circuit. The other is modeling of mechanical stuff, like this one. Now, I ask you, as an electrical engineering student, which is more important to you, the electrical stuff or the mechanical stuff? Okay, no need for me to answer. Okay, this which is important. Okay, so if there's a modeling question, very high percentage that it will be based on electrical circuit. Okay. This you go through this. This is just the basics of feedback control block, and then of course, this is the very important thing. The basic function of feedback control. I'll go through this. 好啦，this is this is modeling of electrical circuit. But this is too simple. Okay, this is too simple. But that is what I call modeling of electrical circuit. Okay, how this electrical you need to study. Okay, I just put important. You need to study how this circuit can be fit into this type of block diagram, and finally you get this. Okay, just the RC circuit. How from a circuit you can transfer to some block diagram. You better get this thing sorted out yourself. Right, so block diagram reduction, I tell you, very important. No need for me to tell you. Every year there is one question on this one. Okay, so you better study okay, block diagram reduction, all these things, all the rules, all these things. I will not go through this. For this lecture, I just want to point out what is important and what is not important. So brush up this technique. Okay. For example, you just go through this step 1, 2, 3. It just gives you a sense of what you should do for block diagram simplification. Now, what I want to tell you is that try to get maximum marks in the first few questions, because the first few questions will be the easier question. The final few questions probably is more difficult to get full marks. Okay, try to get full marks in the first few questions. Okay, so this is block diagram reduction. And then I said it again. Block diagram reduction, very important. Okay, 講完啦. Okay, so finish. Let's go to the next. Then we go to signal flow graphs. I just tell you, very important. There won't be any question exam paper that does not contain signal flow graph. In other words, there will be a question on signal flow graph. And then you will ask, what type of question will appear in the signal flow graph? Actually, there are actually two types of questions. Okay, so let's go through this. The first type is from the equation. I give you a set of equations. You need to convert it into a signal flow graph like this. So it's from equations to signal flow graph, SFG. Okay, this is the first type. These are the things you need to know. So not directly examinable. Okay, so these are the terminology, all these things. The path gain, how to calculate the path gain, or of course all these are important. Okay, the path gain, loop gain, all this stuff. It's the loop, all this. Oh, after knowing all the rules and regulations, okay, this is the SFG. Now, this SFG is not from equation, from circuit to SFG. Okay, also important because you are electrical engineering student. From circuit to SFG. Make sure you notice this. Same thing lah. Okay, wow, 3 examples from circuit to SFG, so you know how important this is. Right, so we go to the Mason's gain formula. I just tell you, this is very, I can't spell, very, very important. Alright, now that's all I want to say about this. So you know what to do lah. Okay, so go through the examples like this one. Okay, all these examples. Right, so this is the end of the signal flow graph. So next is on system modeling. Okay, what is system modeling? Modeling of mechanical and electrical. Okay. Now, just like what I said, what is important? Okay, this one, electrical modeling. Okay, this is important. More important than mechanical because you are not mechanical engineering student. There's some years that we had questions in the exam on electromechanical systems. But this year, I just skipped these questions because usually this type of question is too long, okay, on servo motors, all this. So this one, very, very little chance that you can see in this year's exam paper. But electrical system, you better prepare yourself, okay? This is mechanical, okay? I said this year not very mechanical. Okay, so this one, electrical modeling. Wow. Okay, so important. So I put a star here, means important. Okay, this is still electrical because op-amp is also your electrical engineer. So I put a star here, important. Okay. This is analogy system. Wow, you appear, actually I think it appeared in the past 2 or 3 years. So this will not be repeated because we had question like this one, very similar to this one. So this year we will not, okay? We usually have a few years cycle. So those questions appeared in the past 1 or 2 years will not be repeated again for the coming year. Okay, so this you can forget about this. This is electromechanical. As I've told you, why very long. Okay, very long. Okay, how to test very so I let you off. Okay, it will not crop out in the exam. Okay, so that is it. Ralph Hurwitz and stability. What should I say about this? Let's go through these notes. Okay, all these poles and zeros, all these things, you need to know the basic underlying principle, the operation of all this stuff. Okay, just you need to know all this. Ralph, okay, so this one, I tell you, very, very important. Okay, very, very important. You better prepare. Okay, how to calculate this, how to find what is stability, is it stable or unstable? Okay, all this stuff. Okay, okay, all you need to go through all this lah. Stable or unstable. Okay, all this. I put a star important. Go through the examples. Go through the examples. Go through the examples. This one no need. So no need, because we have not covered in the lecture. This no need. Okay, so if there's any question on the Ralph Hurwitz, you will know. Okay, you already know what is expected on this question. Okay, so prepare yourself, because this root locus every year I see most of the students will get full marks on this one. Okay, try to get higher marks if you want to try to get high marks. This is one of the items that you could just get higher marks. So better prepare yourself. Okay, so that's for this part of notes. Then we go to the root locus. Now I know there's for this part of notes, no need for me to go through it. There's only one thing I would like to tell you. Okay, that is must fully examinable. So there will be one question on this. And what is the form of this question? I give you an equation. Okay, I give you an equation. You plot the root locus law, or sketch the root locus. Now you sketch it on your answer script, and then that's okay. That's it. Okay, not much I need to tell you. So what should you do? You just go through this part of notes, very detailed, look at the examples, so you can answer this question. Okay, you can answer the root locus question. That's all I would like to say to you. Okay, so that's it. For the body plot, same thing. Body plot, I don't need to go through the notes with you. I just tell you there will be a question on body plot sketch. Okay, asymptotes, how to add the things together. So you need to look through the work examples. Okay, so I can tell you what is the question. There's an equation, and then I will ask you, plot the body plot. Okay, like this. Okay, I give you this, you give me this. Remember to put your answer on your lean log graph paper. Okay, that's all I want to say. Okay, so next we go to PID control and tuning. There are let's go through this. Okay, why is it important? Because it's in most of the controllers we know nowadays. Okay, so you need to know what is P control, what is I control, and then what is PI control, right? And then after knowing what is PI control and what is D, so you need to know what is PID control. And then of course very important, this diagram, okay, because this is a summary of PID controller, okay, and this is the equation that is important, okay, or this one in S domain. So these are the important things. I ask you, hey, what is PID control? You need to give me this type of equation. Okay, so you need to give me this type of equation. Now, the next thing you need to know is Ziegler-Nichols tuning. You need to know the procedure, okay? And there are two types, method number 1 and method number 2. You need to know both methods, and then you go through this. What is method number 1, method number 2? You need to go through this, and you need to know these two tables. Okay, so that's all for this part of notes. Finally, we go to the state space control. State space control, you need to know the form of state space control. So let's go through this. This is just talking, not important. This is not that important. This the basic okay. A little bit of important, but not examinable okay. Right. So first is you need what is observable canonical form, and the observable canonical form has this equation. And the next thing is you need to know what is controllable canonical form. Okay. And then the control canonical form, what is the difference between control canonical form and observable canonical form? And finally, you need to know what is Jordan canonical form. Basically, Jordan canonical form is based on partial fraction, okay, based on partial fraction. So the form is like this. So actually, you need to, what you do is that you go to the very back of this part of notes. They are all here. Controllable, observable, and diagonal or Jordan canonical form. Okay, so what you need to do is I will give you a traditional transfer function. You need to know how to change it to XX canonical form. Okay, that's the most important thing for you to know. Okay, I'll give you an equation, I'll give you a transfer function. You need to change it to XX canonical form. And I think that is it. Okay, so we have actually gone through all the notes. So you make sure you study all the notes, make sure you understand them all, and you know how to do the exercise. If you can do this, I'm sure that you will get very high marks. Okay, it's not that difficult, and it's not that long. It's not a lot of stuff to study. Okay, quite straightforward. So not difficult to you okay. So that is the end. Good luck with your exam okay. So make sure you answer all the questions very carefully. Check them, recheck them very carefully before you submit. Okay, so that's the end of this section.